So I wanted to start showing you the PhET molecular shape simulation. I'm going to introduce it to you now. We'll draw out each of the geometries, but I want you to think about potentially having this open in your browser as you're going through the lecture and able to rotate molecules in 3 dimensions as we go through them to see them. I will draw them out for you. I think it's helpful to do that. But it's also going to be helpful to see these molecules and be able to manipulate them. So I'm just going to introduce you to this simulation, and then we'll go through in a little bit and highlight some of the aspects of the different geometries in which we go over. So key points here is that we start off with a central atom. We can add one bond to it. This would be a diatomic molecule, and you can rotate it around, and you could see a lot of things about it. So bond angles. Right now, we don't really have a bond angle because we only have 2 bonds. You need 3 bonds to have a bond angle. You could show the molecular geometry and the electron geometry down here, so you can either test yourself by leaving them off and checking them to see if you're right, or when you're learning, you can just have them on. Now, we can add another bond, and this would give us a linear shape. Okay, so this could be something like BEH2 that has this. We could put a lone pair on, or we could put in another lone pair and make it look something like water. And so you can rotate it around, and we can see how we can have different angles here. We can take off a lone pair, so you can take one off. We can take another lone pair off. We can add double bond, and we can see that we get this planar geometry, so you can rotate around and see what planar looks like, and then make it so that you can really see the bond angles. We can add lone pairs and see what happens. We can just go crazy. So you can get rid of a double bond. Maybe let's put in a couple more, maybe one more, and then we can kind of see this geometry, and then we can see bond angles. Let's remove a lone pair and then add one more, and we can see. Now the key thing here is that this is if we look at these bond angles, these are actually theoretical, and what we see in practice, and when we use valence shell electron pair repulsion, is that the model doesn't necessarily always reflect the reality. And so, for example, if we look at this molecule, it shows that the everything is 90 degrees. 90 degrees, just like if we remove this and then put in another lone pair, we can see that everything, no matter how I turn it, is 90 degrees. Okay. Now, if we go to a real molecule, which is the next step here, and I go to this same molecule, SF6, which represents this, then we could see, okay, electron geometry, bond angle, everything's still 90. Okay, so we see model matches reality when we have no lone pairs. But the one thing I want to point out to you now is that when we have lone pairs, like if we have, let's see, XEF4. Now this actually, the lone pairs were symmetric, and so we still see this 90, but let's get to one in which they're not. So now we see, well, this isn't the one I wanted. Let's do BRF5, yes. So okay, so we go back to the model. We had this model here. We're going to get rid of one lone pair, add in. Okay, so if we look here, we can see that our model shows that the angle at which everything is 90 degrees, 90 degrees. You can't have a bond angle with lone pair, but it's always 1, 2. It goes outer atom, central atom, outer atom, and that's the bond angle we measure. It's all 90, okay? But if we go to our real model, we see that now it's not 90, it's 84.8. So what's happening is you can barely see the deflection, but this is something I want to point out. Look how these molecules are pointing down. These lone pairs are pushing all of these down to make each one of these bond angles a little less than 90 and making this have a little more room. So we're going to get to that and how we're going to explain why that is. But I just want to point out, in this simulation, the model does not account for what we see, and that real molecules actually have different bond angles than we predict, and we'll talk about that as well. So you can go through, we're going to be drawing a lot of these molecules, so as we draw them, you can go through here and rotate them, and that should really be nice to pair with actually watching us do them in lecture.